Today we are going to look at the chapter 5 of class 5 mathematics. Okay, the lesson's name is multiples and factors. Let's see what is multiple. The teacher wants to distribute 3 papers to each student. Find the necessary number of papers when the number of students is 1, 2, 3. If the number of students is 1, then it is going to be 3. Okay, when the number of students are 2, then it must be 3 into 2, that is 6. When the number of students are 3, then the number of papers should be 3 into 3, that is 9. Okay, alright. Fill out the blank boxes in the following table and discuss what numbers come to the boxes. Okay, number of students here 1, here number of papers is 3, 2 means 6. Likewise, we need to fill everything, right? 3 into 3 is 9, 3 into 4 is 12, 3 into 5 is 15, 3 into 10 is 30. Okay, 30. 3 into 20 is 60, 3 into 30 is 90, 3 into 40 is 120, 3 into 50 is 150, 3 into 5 15, so 15 into 10 is 150. The numbers obtained by multiplying 3 by whole numbers are called 3's multiples. All these are 3's multiples. Okay, 3, 6, 9, 12 and so on. So a multiple of 3 can be divided by 3 without a remainder. Okay, for example 6, 9, 12, 15. Okay, you can divide all these numbers by 3 without any remainder. So what is n's multiple then? A number multiplying n by a whole number. Okay, that is the definition of multiple. Circle 4's multiples in the first number line below. Okay, circle 6 multiples in the second number line below. 4's multiple, okay, we'll circle 4's multiple first. 4 2 is 8, 4 3 is 12, 4 4 is 16, 4 5 is 20, 4 6 is 24. If you carefully observe, the distance from here to here is same, 4 plus 4. 3 numbers come in between. Likewise here also, okay, the distance is going to be same. What about 6 multiples? First is 6, then 6 2 is 12, 6 3 is 18, 6 4 is 24 and so on. Okay, here also you can say, you can count the distance. 6 plus 6 is 12, so in between there are 5 numbers. Okay, alright. Alright, 10 multiples. 5 into 10 50, 7 into 10 70, 8 into 10 80, 9 into 10 90. Right. The numbers 12 24 appear in both 3's and 4's multiples. Okay, and are called common multiples. For example, the numbers 12 and 24 appear in both the multiples 3 as well as 4. So these are the common. Okay, 3 4 is 12, 3 8 is 24, 4 6 is 24, like that. The smallest number among the common multiple is called the least common multiple, that is called LCM. Okay, so the least common multiple of these numbers 3 and 4, which are co-prime to each other, is a product of those two numbers, that is 12. Okay, got the point? Right. Look at the number lines in the previous page and answer the following questions. Write 3 common multiples of 4 and 5. 4 5 is 21. Okay, 40 also, you can say 60 also. Okay, Write the LCM of 4 and 5. See, these two are co-prime again. There is no common multiple among 4 and 5. So the LCM is just a product of these two numbers when they are co-prime. Okay. LCM of co-prime numbers is the product of the numbers. Write the multiples of 2 and 3 up to 30. Multiples of 2 and 3. Okay. 2, 4, 6, 8, 10, 12, 24, 26, 28, 30. Here 3, 6, 9, 12, 15, 3, 6, 18, 3, 7, 21, 24, 27, 30. Okay. 2, 7, okay. Here we missed some of the numbers. 14 is there, 16 is there, then 18 is there, then 20 is there. After 20 I am writing it here. 22, 24, 26, 28, 30. Okay. Find 5 common multiples of 2 and 3. Common multiples of 2 and 3. 6 is 1. Okay, we will change the color if you don't like to use the same color. Okay, green is fine. 12 is there. Okay, and 18 is there. Okay, then 24 is there. 24 is there. Okay, 1, 2, 3, 4. 5th is 30 is there. Okay, fair enough. Find the LCM of 2 and 3. Again change the color to original color. 2 and 3, these two are co-prime, so the LCM is 2 into 3, that is 6. Okay, you want me to write it clearly? Alright, 2's multiples and 3's multiples. Okay, the space is given here to write these multiples, so write those multiples there itself. Okay, now find the LCM of 4 and 5, it is 20. What about 6 and 9? LCM means least common multiple, right? The way to find LCM is like this: 6 and 9. 2 is not a factor of 9, okay, but 3 is a factor of both. So start with 3. 3 2 is a 6, 3 3 is a 9. Okay, there are no common multiples here, right? So 3 2 is a 6, 6 3 is a 18. So answer is 18. 3 and 6. Again 3 and 6. Proceed in the same way. 3 1 is 3, 3 2 is 6, 3 2 is 6. 6 is the least common multiple. Okay, like that you have to. You can check the answer as well. Whatever the result you obtained must be the multiple of both the numbers. 18 is a multiple of 6, 6 3 is 18, 9 is a multiple of 18 because 9 2 is 18. Okay, likewise you have to check the answer also. Right, what relationship can you find between common multiples and LCM? Common multiples of 2 and 3 is this, right? But what is LCM? Least common multiple, that is the first one, and here also that should be the first one. Here also it is the first one. Okay, so common multiples are dash of the LCM. So okay, products of the LCM, that we can fill, right? See here, 6 2 is 12, 6 3 is 18, 12 2 is 24, 12 3 is 36. Like that, they are the products of the LCM itself. Discuss how to find the LCM of 4, 6 and 9. Okay, finding LCM, I told you one method, but how the method arrived, how we came to such a method initially you should go like this, right? 4's multiple means 4, 8, 12, like that up to 40. 6 multiple also like this. Okay, 9 multiple like this. Okay, now you have to see which number is there among these three, 4, 6, 9. Common number you have to find, that is the LCM, right? See, 36 is the commonest among them, so 36 is the LCM. Okay, but this is quite arduous to find because it takes plenty of time, right? That's why I suggest you to use the method which I taught you just now. What is the method? I'm not going in the usual way because it takes so much of time. 2 2s are 1, 2 3, 2 2s are 4. Okay, 3 3, 2 2s are 4. Okay, so 2 into 2 into 3, that is the LCM. 2 into 2 into 3, 4 into 3, 12. So 12 is the answer here. Okay, 3 4 5, again 3 4 5, there are no common multiples. Okay, so 4 5 is 20, 23 is 60, that is the answer. When they are co-prime numbers like 3 4 5, the product of the numbers gives you LCM. Now 2 4 8, you should start with 2. 2 1s are 2, 2 2s are 4, 2 4s are 8. Again you can proceed with 2. 1 is 1 only. 2 2s are 1, 2 2s are 4. 2 into 2 into 2 is how much? 8. So answer is going to be 8. Okay, alright. Use of LCM. There are some tiles whose length is 8 cm and width is 6 cm. We want to make a square by paving them on a floor. Find the length of a side of a smallest square. Then that is going to be 6, right? 6 into 6. Observe how the length and width changes when we pave the tiles. Number of tiles. Okay, when you take width as 8, length as 6, like this. Okay, when you use 2 number of tiles, width will be doubled, length will be doubled. 3 tiles, 3 times, like that. Okay, the length of a side of the smallest square is how much? 6 cm. Oh, that must be a multiple of both, right? LCM, in this case you need to find the LCM, that is 24 cm. Okay, it must cover both 8 and must be product of both 8 and 6 because it is not a perfect square, it is a rectangle. In the above questions, how many tiles are necessary to make the smallest square? How many tiles are necessary? 4 tiles, right? How many tiles are necessary to make smallest square? The smallest square side is 24 cm. How many tiles are necessary to make smallest square? What is the length of the side of a second smallest square? I didn't get it right. Okay, forget about it. There are 2 bells, one of them rings every 12 minutes and the other rings in every 5 minutes. If they ring together at 3 pm, at what time will they ring together next time? This is also LCM problem. Okay, again 12 and 5, you can see they are co-prime. So 12 into 5 is the LCM, that is nothing but 60. 5 2s are 10, yeah, 60 minutes. 60 minutes means 1 hour, right? So at 4 pm again they will ring together. You got the point? Right. Bus of company A departs a bus station every 15 minutes and bus of company B departs the same bus station every 25 minutes. If they departed the bus station at 8:45 am together, what time will they depart together next time? Again, this is LCM problem. 15, 25. 5 3 ja, 5 5 ja, 25 3 ja, 75. 75 minutes is the LCM. You have to add this number to 8:45. 75 minutes means 1 hour 15 minutes. Oh, wait a minute. Let me write it clearly. 1 hour 15 minutes. You just add 1 hour 15 minutes to 8:45. 10. So 10 am they will depart together the next time. Okay. Factors. A teacher wants to equally distribute 8 oranges to students. To how many students can he distribute oranges? At max he can give it to 8. Okay. If he is giving only 1, he can give it to 8 students. If he is distributing 2 oranges, then he can give it to 4 members. Okay. If he is distributing 4 oranges, he can give it to 2 students only. If he is distributing all 8 oranges to one fellow, then it will go to only 1 student. Fill out the blank boxes in the following table and discuss what numbers come to the boxes. Number of students: 1 means 8 oranges to only 1. 2 means 4. 3 means no, you cannot distribute because 3 is not factor of 8. 4 is fine, you can give it to 2 students. 5 6 7 no, 8 is 1. Okay, right. So the numbers that can divide 8 without remainder are called factors of 8. The factors of 8 are 1 2 4 8. Okay, the factors always include 1 itself, 1 and itself. Okay, the number itself and 1 both are the factors. N's factor is the number that can divide n without any remainder. Greatest common factor. What is GCF? Greatest common factor. There are 12 apples and 8 bananas. See here in the picture. 8. These are 8 bananas. These are 1 2 3 4. 1 2 3 4 into 3 12. That the teacher can divide these fruits equally. Find the number of students that the teacher can divide these fruits equally. If there are 2 students, each student will equally get 6 apples and 4 bananas. This is the greatest common factor problem. Oh, wait a minute. Alright. Fill out the blanks in the following table and find the numbers that can divide the number of both apples and bananas. Okay, 1 student means 12 apples he will get, 8 bananas he will get. Okay, 2 students means 6 apples and 4 bananas. Okay, 3 means 3 is here, it is not a factor, that's why a cross mark is given. Here 4 means 3 2. Okay, 3 apples and 2 bananas. 5 is not a factor. 6 means 2 here, this is not a factor. 7, both are not the factors. 8, this is not a factor. Okay, that's it. The numbers are 1 2 and 4 that can divide both 12 and Yes, divide 12 and 8 are called common factors of 12 and 8. The largest number among the common factors is called greatest common factor, GCF. Okay, in this case it is 4. Okay, so what GCF here is the 4. Okay, you have to find the common factors. Okay, greatest among the common factor is GCF. Okay, right. Use the following table to find the factors and GCF of 18 and 24. 18 factors are what? 18 2 is 36. Okay, like that you have to proceed. Forget about it. We'll see another example. Find all the common factors and the GCF. I will do only one problem, 12 and 15. Let's say 12. What is the common factors of 12? 12 factors are 12, 24, 36. Oh, sorry. 2, 3, 4 and 12. 15 factors are 3. Oh, wait a minute. 3, 5 and 15 also. I haven't written 1. 1 is also a factor, of course. What is the greatest common factor? In this case it is 3. GCF is 3. Okay, these are the factors of these two numbers, and among them the greatest factor is 3. Find the GCF of 15 and 16. In some cases 1 is the only common factor. 15, 16. Yes, in that case when they are co-prime, 1 is the only common factor, so GCF is 1. What relationship can we find between common factors and the GCF? Okay, what is the relation? Let's see. Common factors are of 8 and 12 are 1, 2, 4. Common factors are 12 and 18 are 1, 2, 3, 6. Common factors of 12 and 15 is 1, 3. Common factors are dash of the GCF. Multiples of the GCF. In this case, is that so? Discuss how to find GCF of 40, 24 and 56. 40's factors, these are 40's factors, these are 24's factors, and these are 56 factors. Okay, see, these common factors are circled here. The greatest among them is 8, right? So answer is 8. That is how you have to find. There is a graph paper of 12 cm in width and 18 cm in length. We cut this paper into some squares of the same size without leaving any remaining parts. Find the length of a side of the largest square. Use the sheet on the right to see whether we can divide it into squares whose side is 2 cm, 4 cm in length without any remaining parts, right? So you need to find GCF only in this situation, 12 and 18. Okay, how to find GCF? Take a small number. Okay, divide the small number with the larger number. 12 ones are 12. Here you will get 6. 6 2s are 12. So 6 is the answer. 6 is the GCF in this case. So what is the answer? 6 centimeter. Okay, so 12 into 18 divided by 6 into 6. This is 6 3 is 12, 6 3 is 18, that is 9. So nothing will remain here in this case. You can use only 9 squares of 6 cm size. Okay, in the above question, how many squares of the largest side can we make from this graph paper? Just now we got it right, 9. Okay, the teacher divides 40 boys and 24 girls into groups without any remaining students, so that all the groups have the same number of boys and girls. Find the maximum number of groups and the number of boys and girls in each group. 40 24. Proceed like this. 24 1 to 24. This is 16, I guess. Yes, 16. 16 1 to 16. 8 will come. 8 2 to 16. So 8 is the answer. Okay. 8 is the GCF. Okay. What is the number of groups then? 8 boys, 8 girls. In the first group, second group, again 8 boys, 8 girls. Third group, 8 boys, 8 girls. Only you can form 3 groups. Okay. Find the maximum number of groups and the number of boys and girls in each group. If you want to find the maximum number of groups, you can make 24 groups as well. Okay, by using only one boy and one girl in each group, you can go up to 24 groups. Okay, anyway, that is not going to be solved by GCM. The teacher wants to divide 60 pencils and 36 notebooks equally to students without leaving any remainder. Find the maximum number of students to whom the teacher can distribute these items equally. If it is a GCF problem, you should proceed like this. 36 1 to 36. This is 24. 24 36 24. This is 12. 12 2 is 24. So answer is going to be 12. Right. So teacher can distribute them equally among 12 students. Okay. Without having any remainder. Okay, 40 24. What is the GCM? Okay, forget about that. There you need maximum number of groups. Okay, calm down. Prime factorization. If the factors of a number is 1 and itself, then it is called prime number. Examples of prime numbers are 2 3 5 7 11 13 17 19. 1 is not a prime number because it has only one factor. Which of the following numbers are not prime numbers and why? Because they have factors. If they have factors other than the number itself and 1, then they are not prime. Like 4, it has factor of 2. 9 also, this is also not prime. 9 is factor of 3. Here 3 and 7 are the factors other than the number itself and 1. Here also this is 49. 33 also, 11 is a factor, 3 is a factor, 49, 7 is a factor. 57, 3 is a factor. Okay. 63, 3 is a factor. 7 is a factor. 9 is a factor. If a number is not prime, then it will be expressed as a product of prime numbers. Like example, 4 2 into 2, 6 2 into 3, 8 2 into 4. Okay, 2 into 2 into 2. Only in terms of prime numbers we can express that. Factorization is called prime factorization. Okay, this process of writing a number, okay, as the product of primes is called prime factorization. Okay, and each factor is called prime factor. I will take only one example here to illustrate. Okay. Alright, 12 means 2 into 6. 6 is 2 into 3. This is 1. 24 also they did it. Okay. 35. Let me do it for 35. 5 into 7. That's it. 35 you won't get many. This is 5 into 7. So we have prime factorization like this. 2 into 6, 2 into 3, 2 into 2 into 3. Okay. Like that you can proceed to find the prime factors. Find the least common multiple of 30 and 45. Divide by common prime factors like I told you earlier. Multiply all the factors. See, first you should proceed with you can also proceed with 2. It is the okay, your 3 is not a factor, so proceed with 3. 3 10s are 30, 3 15s are 45, 5 2s are 10, 5 3s are 15. Multiply them together. 5 into 3 15, 15 2s are 30, 33 is 90. So 90 is the LCM, least common multiple. Okay. 15 and 16, these two are co-prime. Okay, so product of the numbers. If the numbers do not have any common prime factors, then their LCM is the product of these two numbers. Product of these numbers. Okay, there 2 or 3, how many numbers they may be, that must be product. Find the least common multiple of 18, 12 and 14 like this. 2 9s are 18, 2 6 are 12, 2 7s are 4. Again start with 3, 3 3s are 9, 3 2s are 6. That's it. All are primes, right? Now you multiply 2 into 2, 2 square into 3 square into 7. So answer is 252. That is the LCM of those numbers. Let me do it for 8 and 24 and 36. Okay. 2 12s are 24, 2 18s are 36, 2 6s are 12, 2 9s are 18. Again 3 2s are 6, 3 3s are 9. So 2 into 2 into 2 into 3 into 3, that is 8 into 9. How much? 72. So here answer is 72. That's it. Okay, find the greatest common factor. Again you can also find GCF by means of prime factorization. Okay, so divide by common prime factors like this 30 and 45. Okay, multiply all the common factors. What are the common factors? 3 into 3 and 5 in this case. Okay, that is the greatest common factor. This is the easiest method, right? Now what is the greatest common factor? 15 and 16. That is, the numbers do not have any common prime factors, then the GCF of the numbers is the product. product of the numbers. Okay, the numbers do not have any common prime factors, then GCF of these numbers is 0. There is no common factor. Find the greatest common factor of 56, 28 and 42. Again proceed by the method which we discussed earlier. Okay, prime factorization method, 56, 28, 42 like this. Okay, 228 is 214 is 221, 21 is 74 is 72 is 73 is. Okay, so 2 into 7, that's it, because that must be a factor of all the numbers, right? So 2 into 7, 14 is the GCF. Okay, let me do it for 32, 64, 40. 32, 64, 40. 2 is a factor, right? 216 is 232 is 220 is again 2. 2 8 is 216 is 210 is again 2. 2 4 is 2 8 is 2 5 is. That's it. So 2 into 2 into 2 is the answer, that is 8. So here the answer is 8. Okay. Next exercise 5 is waiting for us. Find the LCM. Okay, let me do it. Let me do 20, 12, 25, 32. The last problem. 2 10s, 2 6s, 2 16s, again 2 5s, 2 3s, 2 8s. Okay, now proceed with 5. 5 1s, 3s, 5 5s, 8. Now multiply 4 into 3 into 25 into 8. 25 8s, 200. 200 into 12, 0 0, 2400. So that is the answer for this. Oh, wait a minute, not here. Here 2400. Okay. Find the GCF, greatest common factor. Okay, let me do it this one. 20, 30, 36, 45. Is there a factor which is common among everything? No. 3? No. 5 also? No, straight away no. So the greatest common factor is 0. When there are no common factors, answer is going to be 0. Okay, let me do 24, 28. 2 12s, 2 14s, again 2 6s, 2 7s. So 2 into 2 is 4. That is the answer. Okay. Some trees. Oh, wait a minute. Some trees and street lights are set along the street. Trees are planted every 25 meters, while lights are set every 20 meters. If trees and street lights are set together at the beginning of the street, in every how many meters will the trees and street lights are set together again? That is the LCM of 20 and 25. 5 4s, 5 5s. So 100. Okay. So in every 100 meters they will coincide. Okay. There are 3 bells of different colors. The red bell rings every 18 minutes, yellow bell rings every 15 minutes, and the green bell rings every 12 minutes. If they ring together at 6 p.m., at what time will they ring together next time? Okay, this is also LCM problem. 18, 15 and 12. Okay. 2 9 ja, 2 15 ja, 2 6 ja, again 3 3 ja, 3 5 ja, 3 2 ja. That's it, right? 2 3 ja 6, 6 10 ja 60, 63 ja 180. So after 180 minutes, 180 minutes means 3 hours. So at 9 p.m. Is that correct? Again, let me check it again. 18, 15, 12, 2 9 ja, 2 15 ja, 2 6 ja, 3 3 ja, 3 5 ja, 3 2 ja. Right. 2 3 ja 6, 10, 6 into 10 60. Yes, 3 15 into 20 30, 32 is 60, 63 is 180. 180 minutes only. That is after 3 hours. That is at 9 p.m. If there is a rectangle shape room as shown in figure on the right, we want to pave square shaped carpets of the floor of the room without leaving any space. Find the length of the side of the largest square shaped carpet that can pave the floor. So that must be GCF of 36 and 42. 2 18 ja, 2 21 ja, again 3 6 ja, 3 7 ja. So 2 into 3 6. So in this case, that is 6 meters is the answer. How many such carpets are necessary to pave the floor? 42 into 36 divided by 6 into 6. Okay, 6 7 ja, 6 6 ja. So you might be needing 42 such squares. There are more than 10 students. The teacher wants to equally distribute 42 bananas, 84 biscuits and 105 candies to the students without leaving any remainder. To how many students can teacher distribute the biscuits and candies? Okay, 42, 84, 105. 42, 84, 105, right? Okay, 42, 84, 105. Oh, 105. 221 ja, 2. Oh. Okay. 3 3 1 ja 3, 3 4 ja 12, 3 4 ja 12, 3 2 ja 6, 3 8 ja 24, 3 3 ja 9, 3 5 ja 15. 7 2 ja 14, 7 4 ja 28, 7 5 ja 35. So 7 into 3 is 21. But there are only 10 students. Wants to distribute equally. Okay, wants to distribute equally between the students without leaving any remainder. To how many students can the teacher distribute the biscuits and candies? There are more than 10 students. Okay, 21 is the answer. Just now we checked, right? Okay, is it the end? Yeah, that is the end. Okay, I will meet in this chapter 6. Okay, in the next session. Okay, that's it, guys.